Imagine you're standing in front of two different paths that both lead to the same destination. You still don't know which direction is shorter, easier, or safer. So you decide to take both paths at the same time. Impossible? I would say yes. Physics professors would say, not exactly. Today, I'm going to show you everything we know about the quantum world, from the craziest theories to the discoveries that have already been proven real. But before we enter this parallel reality, please hit the like button. Turn on notifications so you don't miss any new videos. And if you haven't subscribed to the channel yet, this is your moment. So, what exactly is quantum physics? A world of infinite possibilities and almost no certainty. Welcome to the strange and fascinating world of quantum physics. When most people think about physics, I'm pretty sure they imagine that classic scene of Newton sitting under a tree while an apple falls on his head. Classical physics was incredibly important and explains a huge part of the reality we know today. But what if the apple didn't fall down? What if it moved sideways, or even floated upward? Sounds crazy, right? Well, that's the kind of thing quantum physics is all about. Quantum physics is the branch of science that studies the behavior of the smallest units in the universe. Atoms, electrons, photons, and all those microscopic particles you probably learned about in high school. The story began when scientists realized that classical physics, the one based on gravity and apples falling from trees, simply couldn't explain everything. By the end of the 19th century, it seemed like humanity had basically figured out the rules of the universe, until certain phenomena started breaking those rules. That's when a man named Max Planck entered the scene. He was studying the radiation emitted by hot objects and ran into a problem. The calculations from classical physics simply didn't work. To solve it, he came up with a radical idea. What if energy wasn't released continuously, but instead in tiny little packets? And just like that, the concept of the quantum was born, the smallest possible unit of energy. Without even realizing it, Planck had opened the door to a completely new era of physics. Soon after that, none other than Albert Einstein decided to apply this idea to the study of light. What if light was also made of tiny particles of energy? He called these particles photons, and used the idea to explain something known as the photoelectric effect, when light hits certain metals and knocks electrons out of them. Classical physics couldn't explain it. Quantum physics could. Now pay attention to this. Quantum physics discovered that light isn't just a particle. It also behaves like a wave. In other words, light has a double personality. Sometimes it acts like a particle, sometimes it behaves like a wave. And what determines that behavior is the observer. Later in the video, I will explain exactly how that works. But for now, the important thing to understand is that this wave-particle duality became one of the biggest shocks in the history of science. And as crazy as all of this sounds, it's real science, with real-world results. Quantum physics is the foundation of technologies we use every single day. Lasers, computer chips, GPS systems, and even MRI scans. But quantum physics is more than just a set of weird scientific rules. It forces us to rethink what we call reality. It reveals a universe that's far more flexible and mysterious than we ever imagined, where sometimes the impossible is simply a matter of perspective. Now, let's talk about the strangest discoveries. Quantum physics isn't just a collection of bizarre ideas. It's a complete roller coaster of theories that challenge almost everything we thought we knew about the universe. As scientists began exploring the world of particles, they realized they needed entirely new ways to understand reality. And that's when theories started appearing that sounded more like dreams or science fiction movies. The first star of this show is the uncertainty principle, created by Werner Heisenberg. And no, I'm not talking about the Heisenberg from Breaking Bad. I'm talking about the real Heisenberg. His theory says that it's impossible to know both the exact position of a particle and its exact speed at the same time. The more precisely you know one, the the less precisely you know the other. Confusing? Yeah, because it actually is. In the quantum world, certainty is basically an eternal maybe. Another mind-blowing concept is superposition. Imagine a coin spinning in the air. At that moment, it's both heads and tails at the same time. Only when it lands in your hand does it choose one side. Particles behave in a very similar way. They can exist in multiple places and states at the same time, until someone observes them. And this is where the famous Schrödinger's cat thought experiment comes in, a bizarre metaphor created by physicist Erwin Schrödinger to explain superposition. Imagine a cat trapped inside a box with poison. According to quantum physics, until someone opens the box, the cat is both alive and dead at the same time. Only when someone looks does reality choose a final state. Crazy logic, right? And speaking of bizarre ideas, there's also quantum entanglement, the idea that particles can become connected no matter how far apart they are. Two particles could literally be separated by entire galaxies, and if you change one, the other reacts instantly, as if there's some invisible connection between them. Einstein himself called this spooky action at a distance. And finally, there's perhaps the wildest idea of all: parallel universes. That's right. According to some interpretations of quantum physics, every decision you make could create a completely new reality. Every choice opens a different version of the universe. If you had chosen another path in life, reality itself could be different right now. Every decision defines which reality becomes real. So yeah, it's safe to say quantum physicists probably don't believe in destiny. Or do they? And the craziest part is that these theories aren't just weird philosophical ideas. They're helping scientists build revolutionary technologies like quantum computers, while also forcing humanity to question what is truly real, what has already been proven, and what still remains only a theory. The quantum world might sound like one giant, impossible puzzle, but surprisingly, scientists have already managed to decode a huge part of it. And the craziest part? A lot of it has already become technology that we use every single day, without even realizing it. To begin with, quantum physics actually works. And how do we know that? Because scientists have performed thousands and thousands of experiments in laboratories around the world. Things that once sounded like magic or science fiction were tested, measured, repeated, and proven to be real. And from those discoveries came some incredible inventions. Take lasers, for example. That powerful beam of light used in barcode scanners, surgeries, printers, concerts, and even high-speed communication systems? Yeah, that came directly from quantum physics. The word laser actually stands for light amplification by stimulated emission of radiation. Sounds complicated? Don't worry, let's simplify it. A laser is basically a beam of light that is concentrated, perfectly aligned, and made of a single color. Normal light spreads out in multiple directions and contains many different colors. Laser light is different. It's organized, uniform, intense, precise. And all of that is possible because of the strange level of organization happening inside the quantum world. That's why lasers can be used for incredibly delicate surgeries, ultra-precise measurements, printers, USB devices, live shows, and even the internet itself. At the core of it all are atoms jumping between energy levels and releasing light exactly the way quantum physics predicts. And quantum physics doesn't stop there. It also lives inside computer chips, the heart of every smartphone, computer, television, and modern electronic device. According to classical physics, something either conducts electricity or it doesn't. Pretty simple. But in the quantum world, electrons can do something bizarre. They can jump from one place to another, even when, technically, they shouldn't have enough energy to cross the barrier in front of them. This phenomenon is called quantum tunneling, and honestly, it sounds almost impossible. Imagine throwing a ball at a wall, and instead of bouncing back, the ball simply passes through the wall like a ghost. That's basically what particles can do in the quantum world. And without this effect, modern electronics as we know them simply wouldn't exist. It's almost as if an electron can pass through a wall by magic. Inside every computer chip, there are tiny switches called transistors that turn on and off billions of times every second. These transistors control the flow of electrons using quantum phenomena like energy levels, potential barriers, and even quantum tunneling, especially in today's ultra-small advanced chips. In other words, without quantum physics, there would be no chips, no smartphones, no internet, and definitely no videos of dancing dogs on TikTok. But getting back to real-world quantum technology, let's talk about healthcare. MRI scans, the technology that saves lives every single day, also rely heavily on quantum principles. When you enter an MRI machine, it creates an incredibly strong magnetic field. That field forces the protons inside your body to align, almost like millions of tiny spinning tops, all turning in the same direction. Then comes the clever part. The machine sends out a radio pulse, basically an energetic push. This pulse temporarily knocks those protons out of alignment. But just like everything in nature, they eventually return to their original position. And when they do, they release energy. That's where quantum physics steps in again. Each type of tissue, bone, muscle, fat, organs, releases energy in a slightly different way. The machine captures those signals and transforms them into incredibly detailed images of the inside of your body. That's how doctors can see whether everything is perfectly healthy or whether something is wrong. Now, you're probably wondering, what about quantum computers? They're still in the early stages, but they promise to completely revolutionize technology and solve calculations that even today's most powerful computers simply can't handle. Some people even believe quantum computers could one day help us discover the origin of the universe itself. But honestly, not everything in quantum physics is certain. There are still many ideas that remain in the realm of theory. Quantum entanglement is one of them. That strange phenomenon where two particles, even if separated by entire galaxies, seem to instantly affect one another. Scientists have observed it happening, but understanding exactly how it happens and why it happens is still a mystery. Another theory that continues to divide opinions is the idea of the multiverse. The possibility that every decision, every possibility, creates a parallel universe. Like this: if you decided to leave your house with an umbrella today, there could be another version of you in another universe that left without one. And believe it or not, this idea is actually part of serious interpretations of quantum physics. We're not talking about Marvel movies or science fiction anymore. Parallel realities could genuinely exist. Have you ever caught yourself thinking, what if I had made a different choice? What if you had moved to another country, chosen a different career, sent that message you never had the courage to send? Well, according to one of the boldest ideas in quantum physics, those alternate versions of you might actually exist somewhere. The multiverse isn't just a fantasy from movies or comic books. In science, this concept became famous through the many worlds interpretation, proposed by Hugh Everett III back in the 1950s. The idea is simple, but completely insane. Every decision splits reality. Imagine standing at a crossroads with two options, left or right. According to this theory, you make both choices, but each one happens in a different universe. In one reality, you turn left and continue your life normally. In another, you turn right, and your entire story changes forever. And yes, this is considered a serious proposal within quantum physics. It emerged as a response to the famous wave function collapse. The idea we talked about earlier, where a particle only chooses a state once it's observed. But in Everett's interpretation, there is no collapse. Instead, every possible outcome happens, each one in its own universe. So yes, there could be a universe where you chose music instead of engineering, where you quit your job to open a beachside cafe, or where you finally sent that message you've been thinking about for years. Now here comes the million-dollar question. Is this real, or just a fascinating theory? For now, There's no way to prove it. The mathematics behind it are powerful and intriguing, but there's still no direct evidence. But honestly, if one universe is already strange enough, imagine infinite universes existing at the same time. Are we really in control? That's one of the questions that makes people's brains hurt when talking about quantum physics. Does reality only happen when someone is observing it? The role of the observer became one of the biggest crossroads between science and philosophy. Because if observation can influence reality, then what exactly is our role in all of this? Do we create reality simply by being conscious of it? Or are we just tuning into a reality that already exists, like changing channels on a television? And this is where physics begins to collide with philosophy. The question is no longer just mathematical, it becomes existential. Some scientists believe that without consciousness, the universe would simply be a chaotic cloud of unrealized possibilities. Others believe reality is completely objective, and that the observer is merely a witness, not a creator. And that leads us to an even deeper question. What is truly real? If observing something changes the thing being observed, can anything ever be considered absolute truth? Or does everything depend on perspective, choice, and timing? Quantum physics invites us to see the universe as a stage, where consciousness may be just as important as the laws of nature themselves. Maybe the real question isn't whether we're in control. Maybe the question is how we participate in this massive quantum spectacle we call the universe. And who knows? Maybe we're not just the audience. Maybe we're also the actors, without even realizing we're already part of the play. Whether parallel worlds truly exist or not, nobody knows. But it's fascinating to imagine how different our lives could have been if we had made different choices. Could there be another version of me somewhere, living a completely different life? Maybe as a musician, maybe as an actor. Who knows? Tell me down in the comments, do you believe in parallel realities? And if you do, what do you think your alternate life would look like? And don't forget to support the channel.